Dear children, welcome to this channel. We have seen the Vieta's formula to form a polynomial equation of any degree given their roots in the previous video. Now, in this video, let us see how we are applying the formula by some examples. Okay. So, to begin, first let us see the second sum in exercise 3.1, which is the direct application of the formula, and then we can pass on to the examples. Okay. First, let us recall the formula. Okay. So, given alpha 1, alpha 2, etc. to alpha n be the n roots of a equation, let us see what is the formula to find out the equation of a polynomial equation of n degree whose roots are alpha 1, alpha 2, etc. to alpha n. Okay. So, the sum of the roots, that is alpha 1 plus alpha 2 plus etc. alpha n, is denoted by sigma alpha 1. Okay. So, the sigma alpha 1 represent the sum of the roots, all the roots, all the n roots, that is alpha 1 plus alpha 2 to etc. to alpha n, and this can also be denoted by sigma suffix 1. Likewise, sigma suffix 2, this notation denotes the sum of the product of the roots taken by 2 by 2. Okay, that is alpha 1 alpha 2 alpha 1 alpha 3 etc. to alpha n minus 1 into alpha n. Similarly, the notation for sigma 3, that is the sum of the roots, the sum of the product of the roots taken 3 by 3. Okay. Likewise, after getting sigma n, that is the product of all the n roots, what is the formula to find out the equation? That is x power n minus sigma 1 into x power n minus 1, then plus sigma 2 into x power n minus 2 plus etc. That is alternative minus plus. So, the last one would depends upon the power n minus 1. So, it depends upon the factor minus 1 the whole power n minus 1 the sign, and that into sigma n is equal to 0. So, this is the formula to frame the equation, polynomial equation of n degree given the n roots. We are going to apply this formula while doing problems. Okay. See, exercise 3.1 second sum is construct a cubic equation with roots. So, 3 subdivisions are given. I am going to do the third one. So, just you have to see how we are applying the formula directly. The third subdivision is the given roots are 2, 1 by 2 and 1. So, first let us find out what is sigma 1. That is, sigma 1 is nothing but sum of all the roots, that is 2 plus 1 by 2 plus 1. So, 2 plus 1 is 3 plus 1 by 2, 2 3s are 6, 6 plus 1 7 by 2. Okay. Then sigma 2 represents the sum of the product of the roots taken 2 by 2, 2 at a time, that is 2 into 1 by 2 plus 2 into 1 plus 1 by 2 into 1. First take 2, multiply with other 2, and then take the second root, multiply with the third root. Okay. So, 2 into 1 by 2 is 1 plus 2 plus 1 by 2. Again, this is 3 and a half, that is 3 plus 1 by 2, which is nothing but 7 by 2. Then sigma 3 is nothing but the product of all the 3 roots, because only 3 roots are given. So, you have to multiply all the 3 to get sigma 3, that is equal to 1. Right. Now, what is the equation? The required equation is x cube. You have to, as 3 roots are given, you are going to get a cubic equation. So, you have to start with x cube, then minus the coefficient of the next x squared will be minus sigma 1 into x squared. So, the coefficient of x squared should have the sign minus, and it will be minus sigma 1. Then next one should have the sign plus sigma 2 into x, and then minus sigma 3 equal to 0. So, substituting the values, minus sigma 1 is 7 by 2 into x squared, then plus again 7 by 2 into x, then minus 1 is equal to 0. So, you have to, you should not stop the equation with the fractional coefficient. So, let us convert it to integer. That means you have to multiply throughout by the denominator 2. So, on multiplying this, you will have 2x cube minus 7x squared plus 7x minus 2 equal to 0. And this is the required cubic equation whose roots are 2, 1 by 2 and 1. See, in the same way you can try the first one and the second one. Okay. Example 3.1. If alpha and beta are the roots of the quadratic equation 17x squared plus 43x minus 73 equal to 0, construct a quadratic equation whose roots are alpha plus 2 and beta plus 2. See, in the previous exercise problem, we have seen that given the roots, we have directly found out sigma 1, sigma 2, sigma 3 and we frame the equation. Okay. But here, the value of the roots are not been given, but they have given that alpha and beta are the roots of a given quadratic equation. And then you have to frame an equation whose roots are that alpha plus 2 and beta plus 2. So, instead of finding exact value of alpha and beta from the quadratic equation, we can find out the quadratic equation. That is, without finding the value of alpha and beta, we can frame the quadratic equation whose roots are alpha plus 2 and beta plus 2 by using the relation connecting the coefficients and the roots. Okay. So, you know that sum of the roots of a quadratic equation. For a quadratic equation, you know that is the same thing. We are the Vieta's formula. We have used sigma 1, sigma 2 and sigma 3. In the quadratic equation, instead of using the symbol, we can directly use sum of the roots and the product of the roots only, as two roots are there. Okay. So, what would be the sum of the roots? Alpha plus beta, and this is nothing but minus b by a, that is a relation connecting the roots and the coefficients. Alpha plus beta is equal to minus b by a, and the product of the roots alpha beta is equal to c by a. So, with the help of that only the Vieta's formula has been constructed. So, let us use this relation, okay, to construct an equation whose roots are alpha plus 2 and beta plus 2 without finding the actual value of alpha and beta. Now, what is minus b? So, let us use this. So, given alpha and beta are the roots of the equation 17x squared plus 43x minus 73 equal to 0. That means here a is equal to 17 and b is equal to 43 and c is equal to minus 73. Okay. So, ax squared plus bx plus c is equal to 0. This is the general form of the quadratic equation. Now, as alpha and beta are the roots, so first of all you have to find out what is alpha plus beta. So, according to the formula, alpha plus beta is nothing but minus b by a. So, that is minus 43 divided by 17, right. Then alpha beta is equal to c by a. So, what is c? Minus 73 divided by 17. Okay. Then you have to construct a quadratic equation whose roots are alpha plus 2 and beta plus 2. Given the roots, what is the way to construct an equation? First of all, you have to find out sigma 1, that is sum of the roots, alpha plus beta, and then you have to find out sigma 2, product of the roots. Here the roots are alpha plus 2 and beta plus 2. So, what is sigma 1? The sum of these two roots, alpha plus 2 and beta plus 2. So, first let us find out alpha plus 2 then plus beta plus 2, okay. To get the equation whose roots are alpha plus 2 and beta plus 2, first of all you have to find its sum and its product. So, alpha plus 2 plus beta plus 2. So, in order to find this, you have to use this relation alpha plus beta and alpha beta. So, whatever it has been given, you have to convert in the form alpha plus beta and alpha beta so that we can apply its value. So, in order to get the sum alpha plus 2 and beta plus 2, we can rewrite it as alpha plus beta plus 2 plus 2 is 4. Now, we can substitute the value of alpha plus beta as minus 43 by 17 plus 4. Okay. Let us simplify this. So, taking LCM as 17 minus 43 plus 4 into 17, that is 68. So, 68 minus 43, that is equal to 25 divided by 17. Okay. Then sigma 2, that is sigma 2 is nothing but product of the roots. So, the roots are alpha plus 2 and beta plus 2. So, you have to find its product to get sigma 2, that is alpha plus 2 into beta plus 2 is equal to. So, let us simplify this, alpha into beta plus 2 alpha plus 2 beta plus 4. So, whatever it is, you have to try to express this in terms of alpha beta and alpha plus beta so that you can substitute their value, right. So, alpha beta, and then here taking 2 common, we have alpha plus beta plus 4. So, we have simplified this in terms of alpha beta and alpha plus beta. Now, let us substitute the value. alpha beta takes the value minus 73 by 17 and alpha plus beta takes the value minus 43 by 17 then plus 4. Okay. So again taking LCM 17. So minus 73 and this is minus 86. Then again 4 into 17, 68. Okay. So this one is 73 minus 86. Adding the negative numbers, it will be minus 159 plus 68 divided by 17, that is equal to minus 91 divided by 17. Okay. Now after getting the values of the sum and the product, let us find out the equation. So the required equation is x squared minus sum of the roots into x plus product of the roots is equal to 0. That is sigma 1 and this is sigma 2. So as it is a quadratic equation, instead of using the symbol, we can write directly say as the sum of the roots and the product of the roots. Okay. So x squared minus what is the sum of the roots? Sum of the roots is 25 by 17. So minus 25 by 17 into x. Then plus product of the root is minus 91 by 17. So minus 91 by 17 is equal to 0. So to make the coefficients as an integer, let us multiply throughout by the denominator 17. So we have 17x squared minus 25x minus 91 equal to 0. So this is the required equation. Okay. So if you want to find out a quadratic equation given the roots, what you have to do? First of all, you have to find out the sum of the roots alpha plus beta and alpha beta from the given quadratic equation, and then you have to take the roots whose equation are needed and find its sum and product and try to express them in terms of that alpha plus beta and alpha beta, and then after finding the value you can construct the equation by using the Vieta's formula. Okay. This is the method to do these problems. Next example 3.2. If alpha and beta are the roots of the quadratic equation 2x squared minus 7x plus 13 is equal to 0, construct a quadratic equation whose roots are alpha squared and beta squared. This is just similar to the previous example. Okay. So first of all, instead of finding alpha and beta, let us using the relation between the coefficients and the roots, let us find out what is alpha plus beta and alpha beta from the given quadratic equation. Then using that value, we can find out what is alpha squared plus beta squared and alpha squared beta squared to get the quadratic equation for the roots, for these roots. Okay. So given alpha and beta are the roots of the equation 2x squared minus 7x plus 13 is equal to 0. So let us find out what is alpha plus beta and alpha beta. Alpha plus beta is nothing but minus b by a and alpha beta is equal to c by a. So a is 2, b is minus 7 and c is 13. So this is minus of minus 7 by 2, that is equal to 7 by 2. And c by a is 13 by 2. Okay. Then you need an equation whose roots are alpha squared and beta squared. So to construct that, first of all you need its sum and its product. So let us find out the sum of the roots, that is sum of the roots alpha squared plus beta squared. Okay, this is sum of the roots alpha squared plus beta squared. So in order to get the value of alpha squared plus beta squared, you have to use alpha plus beta and alpha beta. So try to express this in terms of either alpha plus beta or alpha beta or both. Okay. So but there is a formula, algebraical identity, that alpha plus beta the whole squared is equal to alpha squared plus beta squared plus 2 alpha beta. So using this identity, we can get the value of alpha squared plus beta squared in terms of alpha plus beta and alpha beta as alpha plus beta the whole squared minus 2 alpha beta. Okay. So substitute alpha plus beta as 7 by 2. So 7 by 2 the whole squared is 49 by 4 minus 2 into alpha beta, that is 2 into 13 by 2, that is 26 divided by 2. Now taking LCM 4. Okay. So LCM 4 here 49 minus, again you have to multiply 1 2, that is 52. So 49 minus 52, that is equal to minus 3 by 4, right. Then next you have to find out the product of the roots, that is nothing but sigma 2. So product of the roots, that is alpha squared into beta squared. So this is simple, alpha beta the whole square. So what is alpha beta? 13 by 2. So 13 by 2 the whole square, that is nothing but 169 divided by 4. So after getting the sum of the value of the sum of the roots and product of the roots, we can use the formula to find out the required quadratic equation. So what is the required equation? X squared minus sum of the roots into x plus product of the roots is equal to 0. That is x squared minus 3 by 4 into x, then 169 by 4 equal to 0. So to make the coefficients an integer, let us multiply throughout by 4, that is 4x squared plus 3x plus 169 is equal to 0 is a required quadratic equation whose roots are alpha squared and beta squared. So without finding the value of alpha and beta, we can directly get the equation by this formula. Okay. Next example 3.3. If alpha, beta and gamma are the roots of the equation x cube plus px squared plus qx plus r equal to 0, find the value of sigma 1 by beta gamma in terms of the coefficients. Okay. So here given that alpha, beta, gamma are the roots of a cubic equation, and you are not asked to find out to construct any equation given the roots using this alpha, beta and gamma, but you have to find the value of sigma 1 by beta gamma. Okay. So for this, in order to find the value also, first of all you have to find out what is sigma 1, sigma 2, sigma 3 given the roots alpha, beta and gamma for the given equation. Okay. So whatever it is, you have to first find out the values sigma 1, sigma 2 etc. according to the equation. Now given alpha, beta and gamma are the roots of the equation x cube plus px squared plus qx plus r is equal to 0. We have alpha plus beta plus gamma is equal to minus p. Okay, minus p divided by 1, that is minus p, and then alpha beta plus alpha gamma plus beta gamma is equal to q. Then alpha, beta, gamma is equal to minus r. Okay. So we know that this equation, that is Vieta's formula says that this will be sigma 1 minus sigma 1 and this will be sigma 2 and this will be sigma minus sigma 3. So according to that we have written that alpha plus beta plus gamma is nothing but minus p, and the sum of the product of the roots taken 2 by 2 will be the coefficient of x, that is q, and the product of all the roots, third roots, will be this coefficient constant, that is the minus sign. So we have taken it as minus r. Okay. Now you have to find out the value of sigma 1 by beta gamma. So 1 by beta gamma means in the same way you have to find out the sum, that is 1 by beta gamma, again 1 by gamma alpha plus 1 by alpha beta. This is the expansion of sigma 1 by beta gamma. Now you have to try to express in terms of either these three. You have to use these three relations. So you have to try to express. Okay. So let us take the LCM. So what would be the LCM? LCM would be alpha, beta and gamma. So here alpha is to be multiplied and here beta is to be multiplied and here it is gamma. So we have expressed this in terms of alpha plus beta plus gamma and alpha, beta, gamma. So let us apply the value. What is alpha plus beta plus gamma? That is equal to minus p, and then alpha beta gamma is minus r, which is equal to p by r. So we have found the value of this one in terms of the coefficient, that is p by r. Okay. Then example 3.4, find the sum of the square of the roots ax power 4 plus bx cube plus cx squared plus dx plus e is equal to 0 where a not equal to 0. This is a quartic equation and it is not a monic polynomial. That's it has a coefficient a, but it should not be equal to 0. That's why it has been given a not equal to 0. Okay. So you have to find out the sum of the square of the roots. That value alone is asked. Okay. So let us take, as it is a quartic equation, let alpha, beta, gamma and delta be the roots. 4 roots. Okay, of the given equation. A x power 4 plus b x cube plus c x squared plus dx plus e is equal to 0. Now let us find out what is sigma 1. What is sigma 1? Sum of all the roots, that is alpha plus beta plus gamma plus delta. That will be equal to minus b by a, right? So it would be minus, the coefficient of x would be, has a sign minus, and it will be divided by a, therefore minus b by a. And then sigma 2, because it is not a monic polynomial, you have to divide throughout by a. As therefore we have getting this alpha plus beta plus gamma plus delta is equal to minus b by a, right? If it is a monic polynomial, it would be only minus b alone. And then sigma 2, the sum of the product of the roots taken 2 by 2. So that is alpha beta plus alpha gamma plus alpha delta, then beta gamma plus beta delta, then plus gamma delta. So this will be equal to the coefficient of x squared with a positive sign, that is equal to c, but you have to divide it by a because it is not a monic polynomial, right? Then sigma 3, it is nothing but the sum of the roots, the sum of the product of the roots taken 3 by 3. That is alpha beta gamma, then alpha plus alpha beta delta, then alpha gamma delta, okay, then plus beta gamma delta. That is nothing but, it is a coefficient of x with a minus sign, so it will be equal to minus d divided by a. Then next to last one is sigma 4, that is the product of all the 4 roots, that is alpha beta gamma into delta, that is equal to e divided by a, okay, alternative minus plus, right? So after getting the values of sigma 1, sigma 2, sigma 3 and sigma 4, let us see what is asked. You have to find out the sum of the square of the roots. So you need alpha squared plus beta squared plus gamma squared plus delta squared. So this, you need the value of this one, okay. So whatever you need, whatever it is asked, you have to try to express in terms of either the sigma 1, sigma 2, sigma 3 or sigma 4, and then you have to apply its value, okay. So as it is a squared quantity, you know that a plus b plus c plus d the whole squared is equal to a squared plus b squared plus c squared plus d squared plus 2 into ab plus ac plus ad plus bc plus bd plus cd. So this is an identity, okay. So by taking a plus b in a group and c plus d in separate group and applying a plus b the whole squared formula, again applying a plus b the whole squared formula for a plus b whole squared and c plus d the whole squared, you will get this one, okay. So using this, we have alpha squared plus beta squared plus gamma squared plus delta squared equal to alpha plus beta plus gamma plus delta the whole squared minus 2 into alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta, okay. So just using the formula and replacing a, b, c, d as alpha, beta, gamma, delta, you will get the required one, okay. So by applying, since using this formula. Now you know the value of alpha plus beta plus gamma plus delta, that is sigma 1 as minus b by a. So substituting here minus b by a the whole squared minus 2 into, and this is nothing but alpha sigma 2, which is equal to c by a. So that is equal to c by a, okay. So b squared divided by a squared minus 2c divided by a. So taking LCM as a squared, we have b squared minus 2ac. So what is the required value for the sum of the square of the roots? B squared minus 2ac divided by a squared, okay. See, in the same way, in exercise 3.1, the fifth sum has been given. Find the sum of the squares of the roots of the equation 2x power 4 minus 8x cube plus 6x squared minus 3 equal to 0. So the same method, instead of a, b, c, d, values has been given. So just do the problem in the same way and get the answer, okay. So I have given the answer as 10. So check whether you will get the same answer, okay.